Hi, today we are going to study Strassen's metric multiplication method, which is divide and conquer method to multiply any two square matrices of size even. To understand what is Strassen's matrix multiplication, let us first see how simple matrices are going to get multiplied. Consider there are two matrices, matrix A and matrix Y. Now X matrix is of size 2 cross 2. There are four components in that, A, B, C and D. And in Y matrix, there are also four components because it is also 2 cross 2 matrix and having an element E, F, G and H. Now if I want to multiply these two matrices, we are first multiplying A with E, then B with G. Then we calculate A with F and B with H. And this way we have produced our first row. Similarly, EC is multiplied with E plus D is multiplied with G. And C is multiplied with F and D is multiplied with H. And this way we have produced our final result of 2 cross 2 matrix. So this is A into E plus B into G as my first component. A into F plus B into H as my second component. Likewise, the matrix multiplication is carried out. If we are going to write an algorithm for this matrix multiplication method, it would be like algorithm to multiply two matrices X and Y, which is also going to get calculated in third matrix C. So that is for I is equal to 1 to n, for j equal to 1 to n, C of ij, that means the final matrix column and row number ij is equal to set to 0. Now for k is equal to 1 to n, C of ij is equal to C of ij plus xik into y of kj. So this is the standard matrix multiplication algorithm. If we are going to apply 2 cross 2 matrix getting multiplied with 2 cross 2 matrix, how many total multiplications are done? From this final matrix or resultant matrix, calculate how many times multiplications done. 1, 2 multiplication in first component, 2 multiplication in second component, 2 multiplication in third component and 2 multiplication in fourth component. So there are in total 8 multiplications and 4 additions performed. So complexity of a given algorithm of standard matrix multiplication is big O of n cube. Now let us see what is Strassen's matrix multiplication. It is a divide and conquer technique for multiplying two matrices. It is being performed with the help of only 7 multiplication and 18 addition subtraction operation. In a divide step, n cross n matrix is divided into 4 different n by 2 cross n by 2 matrices. Now in conquer stage, we apply group multiplication operation of n by 2 size. And in a combined step, we create the final resultant matrix as our output. Let us start with an example. X is a matrix of 4 component A, B, C, D and Y is another matrix of type E, F, G, H. Then we divide them into 4 parts each matrix. So to divide it into 4, we divide from horizontal as well as from middle vertically. So 4 components are now A, B, C, D from matrix 1 and E, F, G, H from matrix 2. Now we will calculate or we will create 7 terms. Let me call those 7 terms as P, Q, R, S, T, U and V. Now these terms are calculated with some formulas. Now these formulas, if you look at them carefully, they are quite confusing. But I can remember these 4 formulas only with 4 rules. Let us see what is that 4 rule and how to develop them. First rule to remember these 7 formulas is ahead. AHED. So we will write down A, H, E and D in our 4 terms P, Q, R and S. But here, make sure the component which is belonging to first matrix will appear as first term and the component which is appearing in the second matrix will appear as the second term always. So A component is from first matrix, it will be the first term. H is a component from second matrix, that's why it will be the second term in second formula. E is also the component from second matrix. That's why it will be the second term in my third formula. And D will be in formula number 4, but it is from matrix 1. That's why it will be my first term in the formula. So rule 1 ahead is complete. Second rule says that diagonal. Now what is diagonal? So diagonals are A and B and E and H from both these matrices. So A and B is appearing as A plus D into E plus H. So this will be my fifth formula. Now third rule is last CR. Last column and last row. From first matrix, I am going to select last column and from second matrix, I am going to select last row. So last column and last row is this. Remember, whenever you are working with the elements of row, use plus sign between them, and if you are working with the column elements, use negative or minus sign between them. So here we have B and D. That's why we will write down B minus D into G and H. I will use plus sign because they are row elements. So I will call it as G plus H. So this is B minus D into G plus H. So this is my third rule and I have done with 6 formulas. Now for last formula, we have fourth rule, that is first CR. I am going to select first column from first matrix and first row from second matrix. So those are A and C and E and F. So the formula will be A minus C because between column elements we use negative sign into E plus F. So we are done with last 3 formulas, but notice above 4 formulas are still incomplete. Now to complete those formulas, we have to make 4 directions. Those directions are P, Q, R and S. So P is second matrix down arrow. Q is the first matrix top right arrow. R is the first matrix below right arrow and S is the second matrix up arrow. So we are going to write P as F minus H because P is a downward arrow from F to H. Similarly for Q, Q is denoting row wise. So I will use plus sign among the elements A and B. So this will be A plus B. For R, I will use C and D component, but they are horizontal, that means row element. So I'll make use of plus sign C plus D. And for S, it is from bottom to top, that is from G to E. So I will write down G minus E. That will be G minus E. This is the 7 formulas of Strasson's matrix multiplication which we have remembered with the help of only 4 rules. Now where is the final answer? Let us see that. To generate final answer, we have 7 components from P to V. So we will make first component as P plus Q as my diagonal element P plus Q. Then I'll write down R plus S. So P, Q, R, S is done. Now topmost column row element is S plus T plus U minus Q. So it will be STUQ. All added, only Q is subtracted. Now here, next last element will be PRTV. Every symbol will have an alternate sign here. So P is positive, R is negative, T is positive and V is negative. So with the help of this particular technique, you can understand complex method of Strassen's matrix multiplication very easily. Consider there are two matrices, matrix X and matrix Y. Both are 4 cross 4 matrix. So there are in total 16 elements in X and 16 elements in Y. So, first step of Strassen's matrix multiplication is to divide every square matrix from middle or horizontally as well as vertically and find out components A, B, C, D, E, F, G and H. So, let us start. This is my component A, this is component B, component C and component D. So likewise from matrix Y, this is E, F, G and component H. So all 8 components have been identified by dividing a matrix from middle horizontally and vertically. We have written all these 8 components for our reference in this slide. Now we will keep on calculating terms P, Q, R and S. Now remember P is given as A into F minus H. So A matrix into F matrix minus H matrix. Now they are going to get subtracted first, then multiplied with A and the resultant matrix is generated. So this is my matrix P. Similarly, I will calculate Q, which is A plus B into H. So matrix A is substituted plus matrix B substituted and the result will be multiplied with matrix H. And the result calculated and obtained matrix Q is this one. So we are here calculated matrix P and matrix Q for U. Similarly, you have to calculate remaining matrices R, S, T, U and V with the help of formulas of Strassen's matrix multiplication. Let me revise RSTUV formulas for you. Matrix R is given as C plus D into E. Matrix S is given as D into G minus E. Calculating T as A plus D into E plus H. And matrix U obtained B minus D into G plus H. Finally, matrix V is calculated as A minus C into E plus F. So here, according to the formula, we have substituted all those matrices A to H and obtained the resultant matrix from P to V. Now next step is to generate the final result. So final matrix is given as P plus Q, P plus Q, R plus S plus T plus U minus Q and PRTV, P minus R plus T minus V. So according to the values of the above matrices, we are going to substitute. So first component is P and Q. We are going to add them and substitute its value in a result in its place. Second component R plus S is calculated and substituted in its place. Likewise, S plus T plus U minus Q is calculated and substituted in its place. And finally, P minus R plus T minus V is calculated and substituted in its final place. So the resultant matrix is obtained as per the screen. I hope you get the method very clearly. Now analysis of Strassen's matrix multiplication. So here If matrix is of size 1, that means if it contains only one row and one column, that means only one element is there, we cannot divide that matrix into two halves or four halves. So, the steps required to multiply two matrices each of size 1 is requiring only one step. That's why we say T of 1 is equal to only 1. If matrix is of size n, then we have to divide it into n by 2 size of 8 parts. And among these 8 parts from A to H, how many multiplications we have done? We have done 7 multiplication each in formula from P to V. In P term, we have done only one multiplication. In Q term also, there is only one multiplication. So there are 7 terms from P to V. So we have done in total only 7 multiplication. And size of matrix in each this multiplication is of size n by 2. That's why we say the recurrence relation for Strassen's matrix multiplication is T of n is equal to 7T of n by 2. Now we will solve this particular equation to find out the complexity of algorithm. So recurrence relation is T of n is equal to 7T of n by 2 and T of 1 is equal to 1. Now using the backward substitution method, we are going to follow the same. Instead of T of n by 2, we substitute 7 T of n by 4. So the complete term is 7 into 7 T of n by 4, which is 7 square T of n by 4. Now instead of T of n by 4, we will substitute 7 T of n by 8. So the term will become 7 cube T of n by 8. If we keep on substituting, we will get our generalized term as 7 raised to k T of n by 2 raised to k. Now, let us assume n by 2 raised to k is equal to 1. If n by 2 raised to k is equal to 1, we say n is equal to 2 raised to k. And k is equal to log of n to the base 2. So let us substitute these values. Instead of 7 raised to k, we will write down 7 raised to log of n to the base 2. And instead of t of n by 2 raised to k, we will write down t of 1. So this will give us the given expression. Now remember, a raised to log of b to the base 2 is equal to b raised to log of a to the base 2. So we will swap term 7 and term n. So the term will be n raised to log of 7 to the base 2 and t of 1 is equal to 1 is given in our initial condition. So the complete expression will be n raised to log of 7 to the base 2. But 7 log of 7 to the base 2 is 2.81 approximately. So the complete expression will be n raised to 2.81. So this is the complexity of Strassen's matrix multiplication algorithm, big O of n raised to 2.81. Thank you everyone for watching this video. This is Munira Topia signing out.